This, this poster presents a research of synthesis of copper oxide nanoparticles using eco-friendly methods and their application in solar collectors. The main goal in this research is to explore the green synthesis of copper oxide nanoparticles using an extract from Hibiscus sativifera, known as Jamaica flower, and their potential to improve heat transfer and system efficiency. The research was conducted in 4 stages. The first one is green synthesis, which refers to produce nanoparticles using an environmentally and sustainable methods. As mentioned earlier, we use Jamaica flower as a reducing and stabilizing agent to synthesize copper oxide nanoparticles. The next stage involves the preparation of nanofluids, which refers to mixing a synthesized nanoparticles with different base fluids like water, ethylene glycol, or a mix of both. Characterization is the analysis and evaluation of chemical and physical properties of the synthesized nanoparticles. In this study, we use UV visible spectroscopy to analyze the optical absorption of the nanoparticles. This allows us to confirm that the synthesis was successful. Finally, we have the photothermal evaluation. This evaluation measures how the nanoparticles affect the fluid's ability to transfer and absorb heat. In this study, we use the thermal lens technique to measure the thermal diffusivity of the prepared nanofluids. It works by focusing a laser beam in the material. This provokes focused heat. The energy of the laser can transform into heat. We change the way the material is affected by the laser beam. A detector is used to measure variations in the laser beam, like intensity and shape, after it has passed through the material. In this study, we use this technique to evaluate how copper oxide nanoparticles, when they are dispersed in a base fluid, affect the fluid's ability to absorb and transfer heat. We found that the nanofluids show a significant increase in thermal properties and diffusivity compared to those who didn't have nanoparticles. This suggests that nanofluids can be highly effective in applications like solar collectors, when improving heat transfer is crucial for improving the system efficiency. This study successfully demonstrates the synthesis of copper oxide nanoparticles using a green method, when these nanoparticles were mixed into base fluids like water and ethylene glycol. They create nanofluids with improved thermal properties. The photothermal evaluation using the thermal lens technique show a significant increase in the thermal diffusivity of these nanofluids, with improvements ranging from 2% to 65%, depending on the concentration.